Hello, this is Dan Alford. Welcome to the ARC Specialties Weld of the Week. This week's episode is brought to you by Mobile Mike, one of our field techs. He was working on one of our lathes, dropped the cast iron pulley and cracked it. There's only a couple of ways to repair cast iron. It can be done with a high nickel rod and gas tungsten arc welding, can be done with shielded metal arc welding, but we're going to be demonstrating some Yestertech today. We're going to braze this. So both brazing and soldering are very similar. In both cases, the filler materials melt at some temperature below the melting point of the base material itself. These filler materials include alloys which contain lead, silver, copper, zinc, tin, and even gold, depending on your application and desired melting point. The differentiation between soldering and brazing is temperature. Below 840 degrees Fahrenheit is considered soldering. Above that is considered brazing. So let's talk about the different tools we're going to need today. We need an oxy-fuel torch, some flux to prevent oxidation, and a filler material, in this case brass, and a grinder to prep the surface. So first let's set up the gas pressures. Today I'm going to be using acetylene as a fuel gas and oxygen. Before you open the valve of the cylinder itself, it's best to unscrew the regulator adjustment until it's not in contact with the diaphragm. This prevents the diaphragm from being damaged when the gas pressure hits it. So once the adjustment is backed off, you open up the gas bottle itself and then adjust the pressure. With acetylene and oxygen, you run equal pressures. I set it up at 20 today. Probably should have been a little bit lower, maybe around 10, because we're using such a small tip. But it doesn't make a lot of difference because the actual flow rate is adjusted at the torch itself. So after you set the oxygen, then I would set the acetylene. Well, some people will tell you that you should open the oxygen valve all the way to the top because it's a double-seated valve. This may be true to prevent leaks, but I like the ability to quickly shut off the oxygen flow if need be, so I just crack the valve. I'll do the same thing on the acetylene and then set the pressure on the acetylene equal to however I set the oxygen levels. Before we start brazing, it's best to preheat the part for a couple of reasons. First, it'll make the part easier to braze, and second, it will reduce the stress by having the entire part expand and contract together. So the way I control the temperature of the preheat is I just heat it till I see a dull red. That means I'm getting a localized area of 1,000 degrees Fahrenheit. Whole part's probably at 800 or so. It's not critical, we just want the part hot. The acetylene-oxygen ratio on the rosebud torch isn't critical, but it is on the brazing torch. The proper technique is to open the acetylene valve first, use a striker to ignite the torch, and then add oxygen. What you're looking for is a slightly carburizing or slightly rich flame. This ensures that you don't have an oxidizing flame, which would be detrimental to the part itself. It's impossible to tell if you have too much oxygen. You can only tell if you have too much acetylene. And the way you do that is there's a cone in the center with a slight feather. If there's a slight feather, that's excess acetylene, and that's what we're looking for. So I've been applying flux to this through the entire operation. That's to prevent this surface from oxidizing as we heated up the part. So I'm continuing to apply flux, I'm continuing to apply heat. Unfortunately, all I had was a double-aught tip, which is a bit small, so this is going very slowly, but you can tell when the base metal is up to the right temperature, because when you apply the brass, it wets and flows much like soldering. So you know exactly when the metal is at the proper temperature. The hardest part of brazing cast iron is that first layer. Once you get that first layer down, it's easy to continue to put brass on top of brass. If you have an area where the cast iron won't accept the brass, that's probably due to oxidation or carbon. And if you hit it with a grinder, or better yet a file, you can typically get it to take the brass, and then you can build up your part once you have that first layer down. One interesting thing about brazing is typically the remelt temperature is actually higher than the initial melt temperature, and you use that to your benefit. So rather than having that entire brass deposit drip and fall off the part, it's actually melts at a slightly higher point, and that allows you to continue to build brass on top of brass until you think you have it finished. Once I thought I had enough brass on the part, we let it cool for a while and I hit it with a sander. You can see there's a few pinholes in it. Brazing is a perishable skill and I'm a bit out of practice, but these holes weren't going to affect the function of this pulley, so we wrapped it and allowed it to slow cool. After the part had cooled completely, Henry chucked it in one of our lathes and machined the groove to fit the V-belt. Here you can see it finally installed back on the lathe, ready for operation. I just wanted to do this episode today to show you that sometimes Yestertech is the best way to solve a problem. This pulley will outlast me at this point. It is said that welding is part art and part science. This is a great example. We're using an older technology to solve a problem. In this case, it's simply a repair. But don't underestimate brazing. Brazing is still used for aircraft engines and all sorts of complex parts. We look forward to posting new episodes of the ARC Specialties Weld of the Week. If you're one of the thousands of operators of ARC Specialties equipment around the world and you have a weld that you would like to showcase, please contact us. At ARC Specialties, we thrive on problems. Send us yours.